In the 1700s, we know Canaletto used a camera obscura. Many artists did. This is by Reynolds. Reynolds certainly owned one. It's in the Science Museum in London. He obviously didn't tell everyone. It folds up to look like a book. But in the paintings of Vermeer done in the 1600s, we see the most vivid use of optics. They have a photographic look. This basket is out of focus. The eye does not go out of focus. How did he paint this fabric and the map and this chandelier? By eye? These paintings looked strange to people at the time they were painted. The foreground objects seemed too big, but not to us. We are used to looking at photographs. Professor Philip Stedman built this model not only from the painting, but from 17th century chairs, tiles, etc., that he went to great trouble to find, and discovered that, viewed from one single point, the view of Vermeer's camera, a photograph of the set, matched the painting exactly. If you computerize Philip's model and project the scene through the lens, the image, focused on the back wall, is exactly the same size as the original canvas. In this model room, you can do the same with several other Vermeers. Only the people and the furniture change. The chance of this happening without optics is millions to one.
You need quite a big lens because of
The light.
you're indoors and you need to see detail, and also you need to project an image the size of the painting, which is, you know, this kind of size, so you need something that will project over that area. You don't need it all in focus at once, because of course you can refocus a bit. But I think that his lens was that kind of size, and that's the sort of lens you begin to get late 16th century, 17th century, early 17th century for telescopes and big magnifying glasses. People making them in Delft. So
I think artists had them first, actually.
do you? Maybe.
Yeah, because images were more important in a way. When we were constructing the wall, one picture we found was a picture by Lorenzo Lotto. I think it's 1545, and there is an elaborate tablecloth. And we could notice at one point this tablecloth goes out of focus. We put it up on the wall because we felt this was quite a clue to something. Our eyes don't go out of focus. Doing it geometrically would see everything in focus. If you're working that out in linear perspective, everything is in focus. So I happened to show this to a new friend, Charles Falco, and he's a scientist, not in the arts at all. And next day, he faxed me saying he'd been thinking about that painting and he realized there were some real clues in it.
That particular painting probably had enough information in it for me to calculate the lens that had been used. Well, over the next couple of days, I made measurements on the painting, and there are several features in that Lotto that are independent confirmation that a lens had been used. In fact, there's so much information in it, I was able to calculate the focal length and diameter of the lens to reasonable accuracy.
What we seem to have found was Lotto's solution with using a lens causing a depth of field problem. When the focus moves from foreground to background, the scale changes. Placed together, the two halves will not match. Lotto had to paint the problem area out of focus.
To the right-hand side of that Lotto, there's a very small but measurable change in the vanishing point at the same depth into the painting as the central feature where it goes out of focus. The laws of geometrical optics prove that Lotto used a lens. And so that's the thing that's different about this. If you understand the science, you realize that this isn't just a nice story. It's a scientific fact.
This proof established an artist using a lens in the 1540s. The change we had seen on the wall, though, happened in Van Eyck's time, more than a century before. We were stuck. There was a huge weight of opinion that artists could not have used optics as early as this because glass was such poor quality that you could not make a good lens.
During the course of conversations and discussions, I happened to mention that, well, of course, a curved mirror also is a lens. And this was a sort of statement that scientists regard this as obvious. A physical scientist knows this, that a curved mirror, like a simple shaving mirror or a makeup mirror in the bathroom, forms an image or can be used to form an image. And David didn't know this.
There's no doubt they had mirrors. I mean, they had convex mirrors. If they had convex mirrors, it's absurd to say they didn't have concave mirrors. It's actually just a piece of glass the other side. Remember, the great image makers, Van Eyck and so on, again, are going to have whatever latest equipment is available, like Hollywood will, or anywhere will.
Concave mirrors have been known since antiquity. They were called burning mirrors. Archimedes was thought to have used burning mirrors to burn the Roman fleet that was trying to sack Syracuse around 0 BC. Well, at the same time you're focusing the sun's rays, you're also forming an image. Now, under normal circumstances, you don't notice the image because the bright glare from the bright sunlight that's focused washes out the image. So it's inconceivable to me that somebody in the right circumstances didn't see an image. And it's obvious to me that Van Eyck saw those images, and the difference between them and others over the 1,000 years before is they were smart enough to know how to make use of it.
Well, here we have a marvelous color projection of the tower. You can see the ivy is blowing in the wind. It's moving. Very beautiful color. This is done with a very simple mirror. And in 600 years ago in Bruges, they were making mirrors, and in the Guild of St. Luke, which was for the painters, they also had the mirror makers. They were part of the same guild. If you want a good image, you have to take some trouble and think of where the sun is and think of all that kind of thing. Just like a photographer carefully thinking about where the light is and so on and so on. Anybody can do it for themselves and see this happen. And it was a surprise to me, a great surprise to everybody else we showed it to. We realized no art historian knew this. Nobody we knew it. And it was a pivotal moment for us finding it. Then finding the size of the sweet spot is 30 centimeters square. That's about the size of the Doge by Bellini. That's the size of the Robert Campion head. This is the size of enormous numbers of early Netherlands portraits. Is that a coincidence? No. I think they found a very, very useful tool which they kept to themselves, as they would. Van Eyck never wrote down any formulas whatsoever for the marvelous glazes he was using. They were not written down, probably in case somebody else got them who he didn't want to have them, who was a rival. meaning they were in business and he needed other things. So he's not going to tell them exactly how he does things.